Okay, shall I guys? Shall I? Now write the heading. That is what? Pulley and block problems. Yes, again pulley. Pulley and block problems. This is a different topic. Over here, what we are going to learn is, let us try to understand. Let me introduce this. Now, in our earlier classes, we have completed what constraint motion now. In constraint motion, we either calculated what velocity or either we have calculated what the acceleration. Did we ever consider the mass? No. Now over here, what we are going to consider what the mass. Mass of what? First thing, block. So we have to consider the block mass. Okay. And obviously, if I am saying the word the pulley, definitely we will be talking about what? String. Yes or no? If we are talking about the string, here we have to separate the string into two parts. That is what? One is massless string and the second is the string with what? Mass. Two things what we are going to learn here. And the third thing, if I am discussing about the string, definitely there will be again the introduction of what? The tension. So we are going to calculate here what? Tension. Okay. And obviously we are discussing about the force. If there is a force, then there will be an acceleration too. Okay. So what we are going to learn in this topic, we need to calculate the tension as well as the acceleration. We need to calculate what? Tension as well as what? Acceleration of what? The system. Okay. Either the system is being connected like this. For example, there may be two or three blocks, whatever the numbers are. You have to calculate what is the tension along this string and what is the acceleration of this system. Definitely, we will apply what? Newton's second law. Yes or no? Newton's second law we are going to apply. That means this is nothing but the application of again second law. How we have applied to calculate what? Normal. Yes or no? Bigger force minus of smaller force, which is equals to mass into acceleration. Yes or no? That is what? Nothing but F net. F net is equals to ma. Yes, same thing we are going to apply. And again over here you will be finding over here the string is massless. Okay, sometime you will be having the system where this string is having some mass. Okay, so massless string as well as with mass. What is happening? We know that in massless string tension remains same, and in with mass the tension at different point is different. Similarly, in pulley system, again there will be a pulley. Either the pulley is fixed, either the pulley is in motion. There are some bodies which are attached. Again, you have to consider the mass here. Here also we need to consider what? Mass. Still, the pulley is massless, string is massless, and there is no friction at all. I got my point? So what we are going to learn? How to calculate the tension as well as the acceleration. I got my point? By considering what? Masses here. Okay? Right on. Okay, shall I? Now the example number 1. Shall I? Now listen to me. How we are going to calculate what? Tension as acceleration. They provide you like this. Find tension or acceleration. Or they may only provide you find the tension. Okay? Now listen to me. Consider here is an example. Consider here is a surface. On this surface, two blocks has been attached with a string or connected with a string. So block A and block B. So this is your A, this is your B. Let's say this one is made of 2 kg and this one is made up of 3 kg. Okay. Still there is no friction over here. Okay. Now consider this block I applied in this direction 500 Newton of force is acting. Okay. And on this block 200 Newton of force is acting. So how many forces are acting on those two blocks? One in that direction 500 and on this block in this direction 200 Newton. Okay. Now how to do in a basic form? First thing, consider block A. If I consider block A, tension at this point, tension is always acting away from the contact point. So this is the contact point. That means for this point the block A, tension is in this direction, and for this block B, tension is in this direction. Yes or no? Okay. Now over here, how much force is acting? 200 Newton. In this direction, tension is acting. Okay. Mg and normal both will be having the same value. Why? Because it is balanced. Yes or no? Okay. Now this one is 2 kg. Yes. Let us imagine the whole system is going in this direction by A acceleration in that one. Okay. If I say body is accelerating in this direction, who will be the greater value, tension or 200? Tension now. So how to write the equation? Bigger force minus of a smaller force, which is equals to ma. Mass is what? 2. Acceleration we don't know. Okay. Consider this as your equation number 1. Okay. Now similarly, let us try to find the FBD on 3 kg. On 3 kg, how many forces are acting? One is acting in this direction. That is what? 500 Newton. And the other is acting in this direction. That is what? Tension. Are yes or no? Where the body is accelerating still, whole system is accelerating in this direction by A acceleration. Are you got my point? Okay. That means, can I say over here 500 will be bigger and T will be smaller. So 500 minus of T, which is equals to ma, that is what? 3 into A. Consider this as equation number 2. Okay. Now what we need to do? Adding equation 1 and 2. If I add this equation 1 and 2, that is what? T minus of 200, which is equals to 2A, or 500 minus of T, which is equals to what? 3A. Adding these two, can I cancel this tension and tension? Yes. Left out will be 500 minus of 200, that is what? 300, which is equals to 5A, or A will be 300 upon 5, that is nothing but acceleration, 60 meter per square second. Are you got my point till here? Okay. Then after calculating the acceleration, we can substitute in any equation, either in equation number 1 or either in equation number 2. I will be getting what? I will be getting what? The tension. Are yes or no? Okay. Now substituting T value is, A value is equals to 60 in any equation. So T minus of 200, which is equals to 2 into 60, this becomes 120, and 200 goes over there, then tension will be, can I say that? 320 newtons. So how we calculate tension and how we calculate the acceleration? First thing, this is the basic step to calculate this thing. Now, or else we already know that we discuss in what during the normal. Normal is an internal forces if two objects are in contact with each other horizontally or vertically, whatever the values are. Then we said that if we consider it as a whole system, we can neglect the internal forces. Over there, normal acts as what? Internal forces. Can I say that if I consider this as the whole system, then can I neglect what? The internal force, that is what? Tension. If I consider this whole as a system, then can I say that this is 2 kg and this is what? 3 kg. Yes or no? Then total what? 5 kg. On this 5 kg, how many forces are acting? One is acting in this direction, that is what? 500 Newton, and one is acting in this direction, that is what? 200 Newton. So 500 minus of 200, 300. 300 divided by that 5, again you will be getting what? Acceleration is equals to 60 meter per square second. I got my point. This is how we are going to calculate. So whenever the question is given, don't start with equation 1, equation 2. Just first find acceleration. Okay, to calculate tension, we need what? The equations. That means FBD on different bodies. I got my point? Right on. Everyone? Now try this. Example number 2. Again find what? Tension and acceleration. And shall I take 3-body system? Okay. Consider here is the example. This is your body 1 connected with one more. This is your body 2. One more is here. This is third. Let's say this is 2 kg. This is your 3 kgs and this is your 5 kgs. And in this direction, let's say 300 Newton is acting. And in this one, on this block, 200 Newton is acting. Question is, first tell me, tension in this string and in this string remain same or different? Different, na? Okay, very good. So find T1. This is your T2. Find T1 and T2 and acceleration of this system. First, solve the acceleration, then draw the FBD for this one, or draw the for this one, or better, you can also do first and third. Your wish. Okay, come on. Okay, shall I? सभी का आ गया ना? Okay, now let me check this. So acceleration कितना है? Okay. So सभी का उतना ही है? Now, so if I see the system, this one is 2 kg, this one is 3 kg, this one is what? 5 kg. Total is what? 10. And in that direction 300 and in this direction 200. Resultant will be 10. Let me check this your answer. So now the body is 10 kg in this direction. 300 Newton is acting. And in this direction 200 Newton is acting. That means, can I say 300 minus of 200 divided by A. So F is equals to F net. A is equals to F net upon M. That is nothing but 100 upon 10. That is what? 10 meter per square second. Sabhi ka itna hi aaya? Very good. Okay, now calculating what? Tension. T1 and T2. To calculate tension, either we first select this one. Okay, so on 2 kg. So I am considering this as named as A. This is your B. This is your C. FBD for A. Okay, on A, this is your A is how much? 2 kg. Okay, on A, where will be the direction of tension? Tension is always away from the contact point. Okay, so this is your T1 and in this direction how much force is acting? 200 Newton. Okay, where should I consider where the body is moving? In that direction? Okay, if I consider whole acceleration is in this direction, who will be greater? T1 or 200? T1, very good. So acceleration is in this direction. So T1 minus of 200, which is equals to 2 times of A. Or we know the value of A, and A is what? 10. Are yes or no? Substituting the value of A, that is 2 into 10 plus of 200, that is nothing but 220, that is 220 newtons. Aaya sabhi ka? Okay. Now, shall I consider the fifth one or the third one? Your wish. Okay, let me draw for the B. Then I will go for the C. Okay. Now, on B, over here is 3 kg, and on 3 kg here, T2 is acting, here T1 is acting. Are yes or no? Acceleration is still in this direction. Who is greater, T2 or T1? T2. So, T2 minus of T1, which is equals to 3A. Are yes or no? T2 we don't know. T2 is equals to T1 is how much? 220. So 220 plus of 3 into 10, that is what? 30. That is nothing but 250 newtons. IIB? Okay, very good. Let me draw the third. That is what? For C. On C, how many forces are acting again? This is C. This is your 5 kg. In this direction 300 Newton, and in this direction T2. Are yes or no? Acceleration is still in that direction. So A. Who is greater? 300. So 300 minus of T2, which is equals to 5A, or we know the value of A is 10. That is what? 300 minus of 5 into 10, which is equals to T2, or this T2 value will be 300 minus of 50. That is what? 250 Newton. Either substitute on C or either substitute on B, you will be getting what? T2. आया सभी को? ऐसे क्वेश्चन ही करेंगे. Either they can provide you 100 bodies. Now we know how to do the answer. First thing, consider or calculate the acceleration. Then what? Tension. To calculate tension, draw the FBD on single bodies. You will be getting tension. Got my point? Okay, right on. Now, shall I? Everyone listen to me. Shall I now write one small subtopic? String with mass. Okay, and whenever the string is having mass, definitely it will be having tension at different point will be different. Yes or no? Okay, consider. Let us try to understand this by example only. So example number 1 on this. Okay, now just listen to me. Easy again. Consider here is the string, and I am zooming this string. Okay, consider this is your string, and this string is given. Let's say the length of this string is given 10 meter. Okay, and given that the mass distribution is uniform. So over here uniform mass distribution. Now, what is the meaning of uniform mass distribution? For example, this one is, let's say the mass is 10 kg. So, this one is having a total mass that is what, 10 kg. Okay. For 1 meter length, what will be the mass of that block? If I cut that, it will be 1 kg. Then second, again 1 kg. Then third, again 1 kg. If all the 1 meter parts, that means total there will be 10 parts. Yes or no? Those 10 parts will be having equal masses, that is each will be having 1 kg. Got my point? Then such kind of mass distribution is called as uniform mass distribution. If this 1 meter is having 1 kg, then other next 1 meter is having 3 kg, then again 1 meter length is having half kg, mass is not uniformly distributed. They will provide you the value. Okay? Then we need to integrate that. Okay? वो कैसा करते हैं देखते हैं बाद में. But now the condition is given that this is a rod or a rope, whatever you want to consider. This string is having a uniform mass distribution and length of this string is 10 meter and total mass is 10 kg. Okay. And consider, let us try to understand this. Let's say here in this direction 300 Newton force is acting. Okay, in that direction, on that particular point 300, and in this direction let's say 200 Newton force is acting. They can provide you, calculate what? The tension. Now we know that tension at this point is different, tension at this point is different, tension at this point is different. So we know that whenever the string is having mass, tension value will be different at different point. Yes or no? They can provide you calculate at midpoint. Okay, they can provide you midpoint to nako 3 meters pe karenge. So consider there is over here is one portion like this. And this portion, we need to find the tension here. We are calculating tension here, and this is 3 meters from here. Then obviously this one will become 7 meters. Are yes or no? Okay, now separating those two parts. Let's say this one is your 3 meter. Okay, and this is your 7 meter portion. And on this 7 meter, this is 300 Newton is acting. And on this 200 Newton is acting. Okay, now what we have done, we just sliced from there and we made two different parts. Okay, now tension at this point is away from over here, that means in this direction. Yes or no? Okay, for this surface, tension will be in this direction. Got my point? But it is at a fixed point now. So tension at particular one point we are discussing. That means this one is also having value of T. This one is also having value of T. We are calculating at this point only. We are not taking tension at one point and over here and another point. We are calculating tension at single point. Okay. So tension is acting in this direction. Okay. Now let us say the whole system is moving in any direction. So this one is having looking like a bigger force. Let's say acceleration is in this direction. Okay, so obviously this one will be moving with A and obviously this one is also moving with A. Now apply the second law. So if acceleration is in that direction, who will be greater? This T will be greater. So T, okay, T minus of 200, which is equals to 3 times of A. Yes, on this one, equation 300 minus of T, which is equals to how much kg? 7 kg, na? Yes. 7 kg. So this becomes 7A. Okay. Now what we need to do? What? We need to adding the equation or just calculating the acceleration by considering as a system. If I consider this as a system, then on this one 10 kg, over here 300 Newton is acting, and over here how much 200 Newton is acting, and this one is 10 kg. That means 300. If I say acceleration is here, 300 minus of 200, which is equals to 10 times of A, then acceleration is 10 meter per square second. Same values, okay. Now substituting the value of over here A, then I will be getting any in either in this one or either in that one. I will be getting what? Tension answer. So T is equals to 3 into acceleration is 10 plus of 200, then I will be getting tension is equals to 230. If I substitute over here also, I will be getting the same answer. Let us try that. So 300 minus of 7a, which is equals to T, or this can be written as 300 minus of 70, which is equals to tension, and that is nothing but 270 Newton. Sorry, 230 Newton. Are yes or no? So this is how we need to calculate the tension. All we need to consider now where the tension is given, where he is asking. If the question is asked at midpoint, then obviously this one will be 5 kg and this one is also 5 kg. Are yes or no? It depends on the length and it depends on the mass according to the given data. Okay? Are you understood now? Okay. Okay. Shall I? Example number 1 or 2? 2. Okay. Example number 2 on what? String with mass. Now listen to me. Consider here is a surface, and on this surface here is one block, and this block is being connected with a string of having mass, and then here is one more block, and values, let's say this one is 300 newtons and this one is having a value 200 Newton in this direction. This one is, let's say, 2 kg. This one is again 3 kg. Now this string is having mass. This string is having mass 10 kg and this one is having a length 10 meter. Okay. Question is find tension. They will provide you like this. Find T and at, let's say, 4 meter. Okay. 4 meter on the string. 4 meter means somewhere here like this. Okay. Now listen to me. First listen to me. After calculating, first calculate the acceleration. What is the total acceleration? You have to consider this as 2 kg, this as your 3 kg, and this is your 10. Yes or no? Total mass of the system becomes 15 kg. Got my point? Okay. After calculating 15 kg, then you need to substitute what? Acceleration. Get the acceleration. Got my point? After getting the acceleration, whenever you are writing for A, now from here to here substitute A. This is your A. 2 kg plus this mass. I got my point? Again 3 kg with left out mass. Got my point? Try this. Okay. Shall I now? Okay. To consider, to calculate what acceleration, we are going to consider this as whole system. This mass is 2, 3 and that is 10. That is 15 kg, and on this 15 kg, 300 Newton is acting in this direction and 200 Newton is acting in this direction. That means where should I consider acceleration? There. Okay. So acceleration is here. So 300 minus of 200 upon what? 15, which is equals to acceleration, and this is nothing but 100 upon 15. This is 5 3s, 5 20s. That is 20 upon 3 meter per square second. Sabhi ka hai ye? Okay. Now acceleration is done. How to calculate the tension now? To calculate tension, we need to consider this as one mass. This whole as one mass. Okay. Equal mass distribution again. That means this one is 10 kg and this one is 10 meters. That means how much length we are talking about? 4 meters now. Are yes or no? So this length is how much? 4 meter. If this length is 4 meter means it will be having 4 kgs. Okay. So 2 kg plus of this 4 kg. How much? 6 kg. Very good. So for A, this is your 6 kg. Over here tension is acting. Over here 200 Newton is acting. I got my point. And for B, whenever we are writing for B, and this is your system for 3 plus of 6, 9 kgs. So this is your 9 kg. Over here 300 Newton is acting, and over here T is acting. Where we have considered acceleration? Here, na. So over here who is greater? T will be greater. So T minus of 200, which is equals to 6A. And those who have calculated for that system, over here 300 minus of T, which is equals to 9A. Okay, now either substitute here acceleration or either substitute their acceleration. You will be getting what? Tension value. So acceleration is how much? T minus of 200, which is equals to 6 into 20 upon 3. This is once, this is twice. So T is equals to 200 plus of 40. That is nothing but 240 Newtons. इतना ही आया. Okay, and those who have substituted here, so 300 minus of minus of 9 into 20 upon 3, which is equals to tension. This is once, this is thrice. So 300 minus of 60, which is equals to tension, or tension is equals to again 240 Newton. किधर भी substitute करो बेटा उधर उतना ही आएगा आंसर. Okay? अरे got my point ना? Right on. Okay, shall I? So example number 3. Now listen to me. Shall I take horizontally, vertically, lifting through the ground? Can I? Okay, चलो सुनो इधर. Consider here is one block, and this block is having a mass 10 kg, and this block is being applied a force in this direction by 1200 Newton. Okay, 10 layer to 1200. Okay, now listen to me. And one string is connected here. This first string is what? Massless. This one is massless. Okay, this string is massless, and this block is also 10 kg. 10, 100, 200. Okay, and one more string is being connected with mass now. Okay, this is your third block, and this is also 10 kg. This is also 10 kg, and tension from here to here same. Yes or no? So you need to calculate this as T1, and over here tension will be different at different point. Let's say this one is having a length that is what, 10 meter and 10 kg. Again, mass is uniformly distributed. 10 meter, 10 kg, and question is 4 meter इधर ले लो. From here 4 meters here. Then left out this one will be 6 meters now. Yes or no? Question is find tension at 4 meter from here. That is what T2, and find tension in this string. Now we are taking this object whole system in the vertical direction. That means there will be mg also. Okay. Now calculate the acceleration, then calculate for this system, then calculate for this system. You will be getting what? Tension. Okay. Come on. Okay. Shall I? Everyone got the acceleration? Okay. Very good. So what is the total mass of this system? 40 na? Yes, you can add one more force which is acting in the downward direction. One force is been added. Mg also added, and one force what you are applying that can be added. Okay, no need to worry about that also. Okay, shall I know? 10, 20, 30, 40. Are yes or no? And this system, let's say, is going in the upward direction. Acceleration, that means, can I say 1200 is being having a greater value? That means this one is 40 kg on this 40, 1200 is acting in this direction. Yes or no? Mg is also acting. Yes, very good. Then Mg, this 100, this 100, this 100 and this 100. That means total 400 Newton is acting in the downward direction. Now, so 1200 minus of this 400, that is what, 800 upon this 40. Can I write directly? So 1200 minus of 400, which is equals to 40A. 40A. Acceleration is in the upward direction now. Are yes or no? Okay. Then can I say this is your 800 upon 40, which is equals to acceleration, that is, this is nothing but 1, this is 20s. So acceleration I got 20 meter per square second. Everyone got this value? Okay, very good. Now to calculate what? Tension. Yes or no? Okay. To calculate tension, T1 will be acting in the downward direction. Okay. Now I will draw the separate things. This is your how much? 10 kg. Mg is acting in this direction, downward direction, and tension is also acting in this direction. That is what T1. Yes or no? And how much force is being applied on this one? 1200 Newton. And those who have taken in this one, then the answer is correct. Okay. So इसका mg भूलना नहीं है आपको. I got my point. Okay. Now, क्यों? बेटा we are calculating tension at this point ना. तो पूरे system का mass क्यों लगाएगा उस पे? I got my point. How many forces are acting on this block? 3 forces. One is tension in the downward direction. Mg is also in the downward direction. Only 1200 is acting in the upward direction. ठीक है ना? Okay. Now, so where the acceleration? Acceleration is upward. That means, can I say that 1200 minus of mg plus of T1. Yes, okay. So 1200 minus of mg and tension both are acting in the same direction, which is equals to ma, and that is nothing but 10 into a. Yes, okay. Now substituting the value of acceleration and acceleration, we got 20. So 1200 minus of this mg, how much? 10 kg, that means 100, minus of T1, which is equals to 10 into 20, that is what? 200 Newton. Can I write like this? Okay, take T1 over there, 200 over here, then this is nothing but T1 is equals to 900 Newton. Barabar? 200 comes over here, it becomes 1000, minus of 100, 900, T1 goes over there. ऐसा घूर के देखता रहे. So T1 is how much? 900 Newton. Now, this is your second system. In this second system, again you have to subtract in two parts. This is your first one and this is your second one. Yes or no? Okay. While calculating what will be the mass, this one will be 4 kg and this one is 10 kg, 14 kg. And this one is what? Or either you can do two times or just calculate on one. Answer will be same. So 10 kg and this 4 kg, how much? 14 kg. This 14 kg is going in the upward direction. Let me write this one. How much? 14 kg, na? 10 plus of 4. On this 4, where is T1? T1 is acting in the upward direction. So T1 is acting in this direction. Okay. mg is acting in the downward direction. That means how much mg? 140 Newton. 14 kg means? Okay. Then T2 is also acting in the downward direction. So this is your T2. So how many forces? Still 3 forces. Acceleration of the system, this point is A in the upward direction. Who will be greater? T1 will be greater. So T1 minus of, can I say, 140 plus of T2, which is equals to 14A. Are yes or no? Okay. Substituting the value and get the answer. So T1, we know how much T1? 900. So 900 minus of 140 minus of T2, which is equals to 14 and 20, that is what? 280 Newtons. Are yes or no? Okay. Then 14, acceleration 20 and beta. 14 to the. Now 280 comes over here, so 900 minus of 140 minus of 280, which is equals to T2. Solve, you will get the answer. Similarly, if you want to write for this bottom portion, how much is the mass? 10 plus of this 6, 16 kg. Are yes or no? For this 16 kg, T2 is acting in the upward direction. ऐसा होगा. किधर बनाऊं? तुम इतना सॉल्व करके बोलो जल्दी कितना है. Then I will rub this side and tell the answer. Right on. So what is the answer here? T2 480. So T2 is equals to 480. 480 Newton. ये सभी का हो गया ना लिखना? Okay. Now listen to me. We are discussing for this portion, na, bottom portion. This is 10 kg and this is 16. Sorry, total is 16 kg. So if I say 16 kg and on this 16 kg, one thing is confirmed, that is 160 Newton is acting in the downward direction. That is what? Mg. Are yes or no? T2 on this point is acting in the upward direction. So this is your T2. Any other force is acting? No force is acting. Now substituting the value, who is greater? T2. So acceleration is in this direction. So T2 minus of 160, which is equals to ma, that is 16 into 20. Okay. Now solving this T2 is equals to 160 plus of this becomes 16 to 320. So T2 is equals to 480 Newton. किधर भी कर ले बेटा, आंसर उतना ही आएगा. Either using that or either using this. Are yes or no? Now we will go to what? Pulley and block systems. Okay.